this is the fifth part of the chapter, benzene and substituted benzenes. This part of the chapter is about the reactions of alkyl substituted benzenes. Okay, now what are the reactions that the alkyl substituted benzenes can undergo? Okay, you can pretty much think whatever the reactions that the alkanes would undergo, it can be applied to the alkyl substituted benzenes. The first reaction is radical substitution reaction. Okay, we know that the benzyl group can undergo radical substitution with bromine or chlorine. Okay, so where the hydrogen on the benzyl, so here is the benzyl group. So the hydrogen on benzyl is going to get converted or is going to be replaced by the bromine through the radical substitution. And once it is converted into an alkyl halide, you can imagine all the reactions that undergo with most of the reactions that the alkyl halides would undergo can undergo with the substituted benzenes as well. Okay, so here is benzyl bromide, and because it has the halogen right here, this halogen can be replaced with any nucleophiles. Okay, so it can react with OH minus to give CH2OH, and it can react with cyanide ion to give to put the nitrile group on it, and then it can also react with ammonia to give amine. Okay, so here is the amine. Okay, and elimination reaction. We know that the alkyl halides would undergo elimination reactions. So similarly, if you have a bromine on the as a substituent on the alkyl part of the alkyl benzene, then it can undergo elimination reactions. So basically this base right here is going to go abstract the hydrogen, and that hydrogen is going to put the double bond right there, and the bromine is going to leave. Okay, so that's the elimination product. Okay, reduction reactions. We know that the alkenes would undergo reduction reaction in the presence of with the hydrogen in the presence of palladium catalyst to give alkanes. So if the alkyl substituent has one or more double bonds, it can also undergo hydrogenation. Okay, so this is catalytic hydrogenation, where you can see that the hydrogen is going to get added to this double bond right here. Okay, and this is a very famous reaction that we have seen in last chapter, which is carboxylic acid derivatives, where the cyano group is actually going to get reduced to an amino group. Okay, CH2N2 in the presence of rank nickel. And benzene is extremely stable compound, but it still undergoes reduction with nickel at a very harsh condition of 250 degrees Celsius and 25 atmospheric pressure. At a very high temperature and high pressure, it's going to give cyclohexane, which is the reduced product of benzene. And you can also reduce a nitro group on the benzene by simply doing the catalytic hydrogenation, where it's going to give aniline. This is aniline. When you have an amino group on, when you have NH2 on benzene, it's actually called as aniline. Okay, oxidation reaction. When you react alkyl substituted benzenes with chromic acid, which is normally used oxidizing agent, it's going to get oxidized to carboxylic acid. Okay, so usually it is only the alkyl group that is oxidized. The benzene part of the molecule, the benzene molecule, is not going to undergo any oxidized because it's very stable. It doesn't really matter what is the length of the alkyl chain, and it doesn't really matter what is the bulkiness of the alkyl group. It's still going to get it converted into carboxylic acid. Okay, so these are some of the reactions that the alkyl substituted benzenes can undergo. Now let's see whether we can do this problem. So here is an alkyl benzene, methyl benzene, which is basically toluene, which undergoes a series of reaction. The first reaction is bromination in the presence of light. And the second reaction is reaction with cyanide ion, and third reaction is hydrogenation with rank nickel. Okay, let's see whether we are able to do this problem. So with the first reaction, we know that this part is actually benzyl group. Here you have the benzyl hydrogens. Okay, and therefore the first reaction is bromination, radical substituted bromination, where it's going to get converted into a benzyl bromide. And you can imagine that this is more like an alkyl halide, which can undergo nucleophilic substitution reaction, where this cyanide is going to go attack this carbon and the bromine is going to leave. And remember, benzyl halides can undergo both SN1 and SN2 depending upon the conditions. Okay, and now this is going to get converted into, this is going to put a nitrile group where the bromine was present. Now, after it is converted into nitrile group, reducing it with Raney nickel is actually going to give the amine. Okay, so this is the product for this